Friends, so today I am going to discuss with you regarding the Parseval's identity, the use of Parseval's identity, and in finding some familiar infinite series value. Okay, like this: 1 by n square, 1 by n to the power 4, 1 by n to the power 6. Okay, so this type of summations are called Riemann zeta function. If you express the function with variable s, okay, so these are called Riemann zeta functions. So uh, you can find this Riemann zeta function in complex analysis. That thing sometime we will discuss later. And so here we are going to use the Parseval's identity that we derived yesterday to finding this series. Okay, so for that, remember, you have to use some function. Okay, you have to write down the Parseval identity for some specific functions, then only you can find this summation. For some particular function you can find this summation, and for other particular function you can find this summation. Means we cannot obtain this value of summation starting with any functions. Okay, you have to use some specific functions, then only you can find this summation, and this summation. Okay, so first we'll write that identity, Parseval's identity again. It is from minus pi to pi. If I write that identity in terms of the variable angle, then fx square dx pi summation a naught square by 2 plus summation an square plus bn square. Okay, so this thing you can remember always, that when we write the Parseval's identity for a complete Fourier series, means not for half range or sine series or half range cosine series, in that case we always write this thing. This pi is here. If I would have written minus L to L, then there it would be L. Okay, so that thing you remember. So now we are going to use this Parseval's identity to find that summation. At first we are going to find 1 by n square, the value of this summation, 1 to infinity. Okay, so for that you remember we have to start with the function fx equal to x with the interval. Means we have to use this odd function to find that this value, this summation of this infinite series. So this is a odd function. So now we remember that who is one of the Parseval's identity we are going to use. Because it is a odd function, we are going to use minus pi to pi, that we can write fx square dx pi. Since it is a odd function, this a0 and an both will be 0. Okay, so inside the summation bn square, only that will be there. So again I would like to remind you that this identity, that for odd function, or that identity for half range sine series, those are similar. Okay, if I will write here from 0 to pi, then we have to write here 2, then 2 will go this side, pi by 2 it will become. Okay, so now since our function is defined in the interval from minus pi to pi, we are simply going to use this in this form, this identity in this form. Okay, so this is the identity we are going to use. Now we will write down the Fourier series of this function first, because from there only we can find the bn value. Okay, so uh, so if you write down the Fourier series of x, then this Fourier series we have written many times, so we know the value of this function Fourier series. It is 2 minus 1 to the power n plus 1 divided by n sine nx. Okay, So since it is a odd function, in this Fourier series we are only having sine series, only sine nx is there, no cos nx. Okay, so this is the value of bn, this is the value of bn. So now we are going to use the bn value in this identity. Okay, so and then it will become, so first we will write this left hand side minus pi to pi. In place of fx square we have to write the function x square, that is the square of that function, dx pi. So here in the inside the summation we have to write bn square. So we know the bn value, we have to simply do the square of that value, minus 1 to the power n plus 1 divided by n whole square. Okay, and that is the only component we have to write. So here it will become x cubed by 3 pi minus pi is equal pi summation, it will become n square 4 1, because if you see it is 1 2 into n plus 1, it will always be 1, because in the power it is 2 is there, so all the powers will be even numbers, so minus 1 to the power any even power is 1. Okay, so after that we'll obtain, I am removing this one, after that we'll obtain, so if you put the limits here, first limit pi cube by 3 minus, sorry, 3 minus pi cube 3 pi summation 4 divided by n square. Okay, so after that it will become pi cube 3 minus minus plus pi cube by 3 plus pi summation 4 n square. Then this will become 2 pi cube 3 pi, if you take the 4 outside it will become 1 by n square. So if you will arrange this one and taking making the subject summation 1 by n square, then you will find it is pi square by 6. Okay, so we have found this infinite series 1 by n square and this pi square by 6. Okay, so for that you have seen that we have started with the function fx equal to x, because in that function when we found the value of bn, so in that bn in the numerator denominator n was there, so because in the Parseval's identity we do the square of that Fourier coefficient, and because of that this n square comes. Okay, so starting with some specific function, what is that specific function here, fx equal to x, we have found this summation. Okay, this is the summation. So now if you start with the function, now if you start with the function fx equal to x square from minus pi to pi, then you will find the summation of 1 by n to the power 4. Okay, because why, in the this Fourier series, for this Fourier series, if you see if you find the Fourier series of this function, then uh, in the this is a even function, is not it, this is a even function. So here what will be the coefficients, a naught will be there and an will be there. Okay, and this a naught, this is n independent, this is dc component, there will be no any n values, and in the an only n values will be there. Okay, so in for that an in the denominator this n square term is there. Because of that, if you when we'll use the Parseval identity, then that square of denominator, it will give the n to the power 4. Okay, so if you start with the Fourier series of this function, and if you apply the Parseval identity for this function, then you will find this one. Okay, so uh, that one you can do by yourself. And for that, uh, if you want to find the Fourier, this infinite summation of n to the power 6, okay, then you have to start with that function x to the power cube minus pi to pi. Okay, so using that Fourier series and Parseval identity for this function, you can find this summation. So it will be coming pi to the power 90, and it is pi to the power 6 945. These values we can obtain from this. Okay, so you can try by yourself. And so I will do this thing in the next video, but from your side also you can try. Okay, so today we have discussed how we can use this Parseval's identity to find this some familiar infinite series summation. Okay, so thank you very much. So if you have any doubt, then you can write me in the comment section. Thank you very much.